So good evening, everyone. So thanks for the introduction, Radhika. So what I would try to do here is, present you the concept of big data and how we can simplify big data. So big data is something that we have been, at least in this software industry, we have been talking about it for about 15, 16 years right now. So and initially it started like a very conceptual basis. Generally we spoke about uh, processing complex data, and at that time, like, we were not very sure about what kind of complexities would come into the data, because IT and software systems have been there in the industry for for a few decades at that time. So we were looking at use cases in the industry per se. So but the technology was there in hand, like, we can process any kind of data, be it structured, unstructured, or data that is lying in bits and pieces everywhere. We can put them together. So the concept was there, technology was emerging, and but the use cases were not that robust. And then started slowly, we started getting into a situation where this internet was becoming very fast. So where this mobile phone penetration increased, everyone starts to own an Android device, a smartphone. So that kind of situation started, changing the entire landscape, the way we would look at a business, way we would look at data. Those things started to change. So prior to that, it was primarily we would see, the software or data. We would use it in financial domain, like banks. Banks would banks would have some kind of something audio. Is everyone okay with the audio? Radhika, is my audio okay? I'm getting a chat
Yes, the
that
audio is
is
perfect.
audio is fine. All right. So okay. So it was primarily in the telecom, and in finance space. We were looking at huge amount of data being processed, because finance, if you remember, the internet banking was there, so you have to go to ATM and use ATM to withdraw cash. All those were required a kind of very robust kind of IT infrastructure to manage it. So that was the starting point in terms of getting proper structured data and managing them. And telecom, say for example, if I'm making a phone call to someone, this call details have to be recorded in the telecom network. Otherwise, the telecommunication company, it's practically not possible for them to go and write down how much this person is using and then finally detect them. So that's not everything happens in real time on the network. So those are like certain kind of use cases that were there. But how about the smaller businesses? How about like manufacturing sectors? How about mining sector? How about healthcare? All other sectors, that's the core is not data and a huge amount of data processing, but for their business to get better, they require some kind of analytics, or to take the business to a next level, they require certain kind of analytics. So that is one kind of issue that came up, so where big data would come to help. Next thing is, like, say for example, an e-commerce company. E-commerce company generally, like Flipkart, Amazon, or any kind of major e-commerce platforms, so they require smaller vendors to work with them in the ecosystem and participate. So the e-commerce company as such, if they have to process, work with all the small setup, the smaller vendors, etc., they may have, may raise invoices manually, like they may scan and send an invoice, etc. So that itself would become a huge amount of several billions of files, invoices they would have. So they need to process it. So that kind of processing in the traditional setup would not be possible. Whereas with big data, because it is an unstructured data, so there are AI and machine learning based programs that would help them convert that into a structured data and give analytics on top of that. So big data kind of expanded the use cases or the landscape that the traditional IT system can handle, because there are certain advantages, like be it the pace at which the data gets generated, or speed at which it would get into your system, and how fast a user has to consume it, access it, and get it in real time. All those complexity is possible. The big data paves way for you. So this big data term is, one side you can say it's only, is it only for big data? No, it's for any kind of data, even for small businesses, where you may be handling like 1,000 transactions a day, or like a few thousand transactions a month. But in case something can enable the business to get some analytics, the right insights, that would help you in taking better decisions and positioning yourself in a better situation compared to your competitor, big data is there for you. So another thing with big data, if you look at it, say for example, there is something called cohort analysis. Like, say for example, I may have a small app, like video streaming app. So like now we have big apps like Netflix or Amazon Prime, and these are major video streaming apps. But small businesses, for example, someone for a regional market has created an app, a video streaming app. So for him, analytics is very important. So, and the investment, he cannot do very high level of investment competing with Netflix or Amazon Prime. But he certainly requires certain kind of analytics. For that, big data is there to help. So with big data technology, now you see like you may not require a complete IT infrastructure inside your office premise. So you can rely on cloud. Cloud is available for you to store data, and you can process and access information and get what is required. And also another advantage is you pay only for what you consume. So those are some kind of flexibilities available on cloud. So which means you really don't go and you buy a huge amount of hardware, invest several lakhs, and then find it probably, I don't require this. So those challenges are kind of taken away with the cloud concept, software as service. So you can deploy a solution on cloud, and any person can use these kind of services. So for coming back to this use case of video streaming application, like the video streaming application. So generally the basic analytics, these kind of small businesses would like to know is, someone visited or watched my app last month, and how many of them are again watching this or consuming video from my app this month. They would like to know, and this requires certain level of getting into the details. They need to understand the customer base, what kind of videos they have watched, and then all this correlation, everything, and the data queries, everything gets accessed and processed and kept for you to analyze. But these are certain kind of questions that the businesses would regularly ask. Okay, last month these set of customers, they bought a bundle for 300 rupees, but this month they didn't buy anything. So what can we do about it? Can we go back to them with a campaign? So if they have to do a campaign, it should make sense, like it should provide return on investment. So whether we should give any kind of promotional offer, all these questions can be answered from the data itself. Or for example, a manufacturing company, they would like to understand the consumption of energy for a particular plant. like say for example they are into dyeing unit, so dyeing unit wants to understand the power consumption pattern. So why particularly it is going down or going up, and why it's going down in this particular kind of season, so what's the issue. So these kind of information, it's not like a very advanced setup, so where the data everything is automatically tracked. So you may have partially captured manually, partially it will be available in some kind of system that is installed. So but you have to bring everything into the infrastructure for you to get the analytics. And you need flexibility in terms of managing these kind of data sets. So that's one area where big data comes into aid you. So big data generally it includes all kind of technology capability that helps you process and provide the analytics. So that's like in the just an introduction on the big data topic. And now why? So partially I had answered it earlier. So why big data provides information to transform business. So you have a business case, say for example this is I'm running this manufacturing unit. My profit margin is very thin, and there is no cushion for me to make any kind of error. Generally in manufacturing units are rejections, and it has to be operation has to be very lean. So how do we transform the business? So for this you require well disciplined data, statistics needs to be available. So some are practically challenged for you to capture it. So these kind of tools comes in aid to capture those information. And when you have information, you may not have the complete set of data, so where you may have some gap, or you have to predict something in future based on the available data. So prediction is possible. And this, like if you have competitor data, you can predict the market changes, and that helps you get into a kind of a advantageous position in this business. And you can also understand what is working, like that heat example I gave you in for this dyeing unit, where consumption is higher, why it's going down. You can understand the root cause of any issue, and you can get real time alerts. That's another thing. So you can set a model, a machine learning model inside the network, and say, okay, so in case today's the consumption is pretty high, give me an alert. So you will get an instant alert, and you can rapidly take an action, like probably there is some employee doing some kind of malpractice, and or he is not monitoring things probably. So those are the kind of infrastructure that you can develop, so that you would have a much more controlled environment with big data. Opportunities. So opportunities are vast. So it's not constrained to very big companies alone. It is also available for smaller companies, smaller businesses. Like I mentioned, you have this advantage of processing data and cloud. So the use cases are big, and primarily, like without our knowledge, if you look at this Google Map, primarily we use for navigation. That is a big data application. LinkedIn, they use big data. So, and analytics also for hiring. Like I come from the software field, so if I want to recruit people, I use LinkedIn pretty much. The data, they have their own set of analytics. It gets processed, and then you don't know how kind of someone is applying, and they see your advertisement, like you require an engineer, etc. So it goes on like that. So that way, e-commerce, if you look at it, like many of you who have used Amazon or Flipkart, etc., if you're going to order any product, you will get a recommendation at the bottom. So that is a big data, machine learning, AI based engine that gives a recommendation to you. Okay, so you are buying this particular phone, so why don't you also buy this uh, additional device like a headphone or anything like that. So those are big data kind of applications. Or for example, you're browsing YouTube and you're watching a particular video. So there is a machine learning recommendation engine based on big data that tells you, okay, so since you watch this video is something you may like it. And then they started monetizing those recommendation advertisement. There are additional revenue that comes into picture. Automobile, we see self-driven car like Tesla is getting in. So that's again big data and AI technology. Telecom, it's everything is based on this big data now. Analytics, healthcare is getting in patient information. Like now we have this COVID scenario COVID scenario where you would see that every day if you Google, you will see how many people are vaccinated and which region, which clusters. And earlier they also developed an app like you can see like the person how far the next person is away from you who has a COVID. So those are plenty of analytics that came into picture. Like travel, so we see travel restrictions, all this managed to big data now. So now it has become like whichever businesses there is certain amount of data that's going to give you an advantage, they are in some way started using big data and big data technology. So these are several advantages. So apart from just the use cases, even from the cost perspective, these are much lower compared to your traditional IT infrastructure. So cognitive tasks. So, and what happened is earlier we had this statistics, mathematics, and the core subjects. They have developed a lot of algorithms and theories. But those theories, if you have to put it into practice, it is computationally intensive. Say, for example, if I have to do a linear regression, I can do it in my pen and paper for a single variate linear regression. But if it is multivariate, it becomes complex. Same thing with decision trees and several algorithms. Some things it's easy for you to do it on a pen and paper, but once it goes to the next level, you need a high intensive computing power. So that is provided by big data, especially now with cloud. You have very powerful system that you can take it for a very low cost. And if you're taking that kind of service, you can pretty well implement any of this algorithm. You get predictive analytics. You wanted to understand any prescription, say for example, or like the social media like Twitter or Facebook or any of these social media, they use big data technology. For example, if I'm a consumer product brand, I'm launching a new product, and when I launch this product, I may like to know the initial impression about this product from my customer. Say I'm like launching a new snack, say a biscuit. So I would like to get, so if there is a branding initiative that is happening and people in the social media would talking about it, posting about it, so instantly I wanted to collect this data. There are APIs to collect this data, process it, and tell the sentiment from the market. So people are talking good about it or bad about it. What is the picture? In addition to this, there are advanced level of analytics. Such as collect image from the network, and from those images they will get insights. They'll say, okay, so out of this 1 million images that I had collected, half of them have people, and among them 80% are smiling. So which means they are happy with your product. So those are certain kind of inference that you can take from these kind of analytics. So those are like going pretty advanced level of analytics. And next, another thing is like voice processing, etc. So you say, for example, if there are several video recordings, but probably we would like to scan them and understand, like pick some keywords, whether they have spoken about a particular thing. So those are engine technology that supports us in this kind of scenario. So that happens. Or fraud investigation, so we can use it like fraud investigation, because the fraud patterns would keep changing. So we may have to take multiple cues and then process and say, okay, this kind of transactions are fraudulent transactions. So it is tremendous, like in terms of any kind of cognitive tasks. So it's possible with big data. So for the business side, it's about getting better. So businesses always strive to get better, like you get faster insights, you can predict the future, and predicting any kind of problems or any kind of opportunity helps you get better revenue, and you can investigate, cut down your cost, and you can understand where you have to invest more. Those kind of insights come in. Say for example, in telecom, the telecom players can understand what is happening in their competitor network. Say for example, in India we have Jio, Airtel, and Vodafone Idea. So these are the three major players, and BSNL is there. So from Jio side, they wanted to understand uh, what is the market share of all other players based on the incoming calls and the outgoing calls. They can understand, so this is the market share. So how the market shape is changing. So there are certain reports that the external agency may do, but inside Geo they can understand these kind of information too. So that is transformation. And also for audit, say for example, I wanted to ensure that the policy that I have set in the business is happening as we have said. Say for example, in telecom network or in banking system, so there could be scenarios where the banks may say, okay, so these kind of savings account, they should not withdraw above certain threshold. So at transaction level, they may have their staff, everyone doing those, enforcing that. But at audit level, second level, they have to process the data and ensure that there is no violation. So that is easily done with big data, and business transformations are there. So with big data, what we get? So with the new technologies, we can process planet scale of data. So that means like there is no cap on the amount of data. So that's what we are trying to say. And we store, manage data at will. So some data we may not want to store it. So which means we would just take the insights. Say for example, social media, Twitter data, like kind of gets generated in plenty. So if I want to analyze my new product launch and how the customers are reacting in Twitter, I don't have to store that data. I just need to monitor and take what I needed. So the rest of the things, it's not needed. It just gets in, and I get my insights and I move on from there. So it's not like I really need to keep them. So at will I can store and I can manage, but certain things I take what I want. And the variety of sources and the data formats can be any. So for example, images I can process, like a scanned image or scanned invoices we can process. So traditionally it was not possible because your system was not that robust. It requires artificial intelligence. And then you can have multiple sources giving you information, and we can decide on, or we can also take 2 3 sources and say, okay, so which is the best one I can decide on. And we can scale as we grow. Say for example, if your business is pretty small right now and you are investing in big data technology, so you don't need to plan for the next 3 years and buy a huge machine. You can buy a small machine, you can process the data, you can invest in it, and slowly you can scale it. We would say, okay, next year you can add. Or if you're in cloud, even more flexible, you just take a small machine and you pay them that much. As your business grow, you can keep increasing it. So scaling is easier, and multiple teams can run queries and get insights from the data. So that is possible. and integration with wide variety of application. That's more important. More popular big data frameworks are open source, so that gives you more flexibility. So since it is open source based, so if, say for example, if my company Gamma Analytics is building you a solution and delivering something to your company, you can always take ownership of that, and you say, I will improve it, I will get another team, and I can take it to the next level, because these are based on open source. So that flexibility is there. You can visualize multidimensional data, and you can also have a self-service dashboard, which means say for example, you got a consultant or a analytics company to build some analytics for you. So tomorrow you wanted to add more KPIs, more dashboards. If it's a self-service, you can make changes. It gives you more flexibility. So those are the advantages. So this where there part of this was there even before big data era, but things have improved now. Say for example, big data versus Oracle, just giving you a comparison. Oracle is a traditional one, and even still most of the banks and traditional businesses, they still have their database in Oracle or any structured database like MySQL or Microsoft SQL. But now with big data, affordability has increased, and you can have structured data as well as unstructured data, and scalability becomes better. Like, you don't, if say for example you have a hardware, tomorrow you need to improve, or your volume is increasing, you don't need to scrap your hardware. You can always add more nodes to the existing hardware and process it, whereas in the traditional setup you would require a bigger machine. So if it's a database server, you would require a bigger database server, so the old machine has to be scrapped. So that is changing now with this one, and if it is with cloud, it gives you more advantage. So cost wise we get benefits too. So it's a model solution in the nutshell. It's distributed, helps you with fault tolerance. You can get real-time analytics. Accuracy, it's the same. It's both. You have without accuracy, you cannot rely on any solution. Query response is faster, and you have kind of very flexible architecture. So depending on your requirement, you can fine tune it. Integration becomes seamless. Platform agnostic, scalability, predictability, configurable, and resilient. So for the new approaches, you can adopt big open source big data components. You can play around with it. That flexibility is available, and in real time you can make it available. And all it takes, like, you just need some bunch of consultant for you to build a system that you need. So it becomes simplified now. And also there is a concept called data pipeline, so which means you can handle streaming data. Say for example, if you're watching a video, that comes with a streaming data pipeline. Or say for example, if you're doing any kind of e-commerce transaction, and this recommendation engine will be based out of streaming pipeline. Like if you're booking a cab through Uber or Ola, so that happens through streaming pipeline. So these are the kind of advancement that helps in the even for the day-to-day activities that we perform, like be it ordering any ordering food from restaurants. Like there is a tracking that you see in real time. Like if you're getting anything delivered through Zomato or Swiggy, like that, they would say, okay, so where is your shipment now? Or even courier deliveries, etc. The tracking is very solid. Like they will exactly show where this person is at this point of time, and how long he is going to take to deliver anything. And there is something called OLAP, it's online analytical processing. So this kind of pre-summarizes and keeps it, so it kind of gives you faster response. And then the final layer, BI tools, where you can visualize, you can see the charts and dashboard, etc. So just to give a kind of the streaming pipeline, how it would look like. So whenever the data gets generated, It's we call it as producer. It produces an event, and Kafka is a streaming pipeline. So data gets in here, and the processing happens. And in case you wanted to do any kind of lookups, get enrichment, it can happen here. It can happen here, and then goes to your storage. And many times what happens is you will also get results directly come here. Say for example, you want an alert if something is pretty abnormal, you can get it directly from here even before getting into the storage. So those are kind of flexibility that we have, and kind of resolves the issues that we were facing in the traditional systems. So some of the architecture, so this I'm not going to get into this thing. So there is some basic data pipeline. It kind of sequentially gets in, and finally you get it out inside. The operations would happen. And the batch ETL, the older way, you extract, then transform, and then load, and then finally it's available for you. And then you have streaming data pipeline. So data sources, you have streaming platform, multiple streaming application would give you information. And then intermediate, you can have delivery apps, and then various analytics are available. So those are like different kind of architectures available. So depending on what your business need, you can come up with your architecture. So legacy versus big data differentiation at a high level. So initially legacy systems, it's non-standard and error prone, so that happens because of scripts. So now we have seen, like, we work with workflow pipeline and Spark, etc. So this kind of makes things better. And database, initially it's Oracle, expensive but not scalable. So scalable means you have to pre-plan it, your hardware will become difficult. But right now it's all open source, distributed, and on demand scaling is possible. And OLAP, so there was older Oracle OLAP, so this was much slower. But now we have Kylin Presto, and these kind of things helps you with a faster query. And visualization, now we have more flexibility. Also, these visualization tools you can always connect to the legacy system also, so that flexibility is also there. And another thing is big data technology, you would still use the legacy system. So say for example, I can partially use some of the uh, sources for my with the new database, but something I can still use my old database. So that flexibility is there. So you would have, you can kind of, your architecture can evolve with big data. uh, yes, so this is one of the data lake projects that recently we are working on. So these are the data sources from telecom operator. Say for example, IN means is intelligent network. Say for a user who's using prepaid phone, for example. So when you are making a phone call, so before the call gets connected, the telecom network has to check whether you have sufficient balance to make the phone call, whether you are authorized to make the phone call, and then the phone gets connected, like whether the other person is authorized to receive call, also check has to be done. So there are multiple checks. So this call from connection till the call getting established and all the way till it has to end, all this information, what's the start time, how much charge, how much is billable charge, how much is the total time. So there are several level of data that has to be captured. So all these are captured in something in a binary format, not in a readable format. So that format requires complex level of processing, and from there it gets into your system for analytics. So like that, the data browsing, say for example you are watching a movie or anything like that, at a high level there is something like an APN, they will say. So this, you have consumed this thing with Facebook, this with this level of sites, etc. All this is available with the telecom operator. So all that gets in as an analytics for them, and they need to calculate the revenue. They need to understand why customers are not happy, which set of customers are churning, who are moving from our network to other network, like Geo to Airtel. All that information story is available with the telecom network. And big data technology helps them unleash why this is happening, what is happening, if someone is fraudulently attacking your network. So those things are also captured and stored. Something are required for police investigation, all those are stored. And kind of this kind of architecture kind of solves that problem. So here you have Kafka for streaming and Hadoop big data platform, and then Kylie Jen's OLAP, and then Tableau for final visualization. So yeah, so data pipeline, it can be anything, file, or your Kafka can be a data source, and then it goes in and out. And it can be any kind of data source, and you will have multi-stage transformation, complex kind of enrichment, because when you get a phone call, your phone number is not going to be complete, it will be partial. So then there are ways to make it complete, and from there we need to understand the location and from which cell tower the last call was made. So there are several layer of transformation and enrichment that happen, and finally it gets stored and the reporting is performed. So the data that we see in big data, there are, like, since it's kind of multiple machines, it's distributed, you require a lot of monitoring. So this is how the monitoring happens. Like, you have network level, or how by CPU, or where is what the processing memory, how it is stored, all that you can check. And these are some of the screenshots, like how you build a model in big data. This is Kylie Jen's. So you can drag and drop different data sources, build relationships. And if you wanted to transition from your traditional data source to big data, you can always start with some limited scope, limited sources, do a pilot project, check if it meets your requirement, go in for a small investment, or you can try it with cloud, set up a cloud account and see if that meets your requirement. Cloud are becoming very secure nowadays, so no need to worry about the security aspect. Some cases, regulation says you cannot share the personal information, so you can always mask it and send it to cloud. And you can calculate your ROI, return on investment, and then finally build your resources, a new technology, and then you can go into the big data ecosystem. So these are some of the charts, visuals that you can get with big data. Here's some samples. So yeah, so that's what I wanted to present you today for this simplifying big data. So it's kind of, if you look at it, it's pretty simple in nature, but you need to understand the different terms, different systems that is present in the big data ecosystem, so that it becomes much more simpler in terms of managing or implementing it. So thanks everyone. So Radhika, we want to take any questions, or how we wanted to proceed?